doing. Okay, so this is what we were doing. That is, we said instead of having some kind of a square term, we can also interact the terms. So we can allow the slope of one variable to vary depending upon the level of another variable. Okay. So for example, let us think about the effect of education on wages. Okay. So we may believe or we may think that, okay, the effect of education on wages is different for males and females. So that means the slope of that line, the relation between education, and wages, this relationship is, there are two lines. One is for males and one is for females. Maybe it starts at same, but with females, it's slightly lower for whatever reasons. Okay. Then you may want to allow for different slopes for males and females. So you may want to interact the indicator variable for male or female by multiplying it with the education. So let's say, so what will happen is you will have a column for education where you observe the education for person one was 12 years, for another person was 16 years, for another person it is 20 years, and so on. And then you will include a gender indicator variable. Gender is one if it is male, maybe this person is male, this person is female, and so on and so forth. Then you will have the another variable which will be the product of these two variables, education times gender. So this will be 12, this will be 16, this will be 0, and so on. So what you are doing is you are allowing different slopes for male and female. So your hypothesis may be that that education has different effect on wages for males and females. So the causal diagram that you are interested in looks something like this. This is education, this is wages, and this relationship is affected by your uh, by your gender. Okay. Note how the arrow is towards the arrow, not towards the variable. You remember the birth weight smoking problem? Smoking affects mortality, and birth weight affects mortality. Smoking affects birth weight. So here we said that birth weight doesn't affect the relationship between smoking and mortality. Smoking affects mortality through birth weight. So birth weight acts as a mediating variable. The relationship is mediated by the birth weight. Whereas in this diagram, what we are saying is that the slope of education on wages is impacted by the gender. Okay. So what is happening here? Just try and understand how to analyze this. Okay. What is beta 1 hat telling you? Beta 1 hat is telling you the effect of changing x1 by 1 additional year when x2 is 0. When x2 is 0. Why when x2 is 0? Because if x2 is not 0, then the effect of education is not just beta 1 hat, but it will also be impacted by beta 3 hat. I repeat, if you don't hold x2 to be 0, then your effect of education on wages is not just beta 1 hat, but it will also have a component of beta 2 hat. Why? Because how do you calculate the partial effect of x1? It will be beta 1 hat plus beta 3 hat times x2. Note that when you are differentiating with respect to x1, x2 is a constant. We are taking a partial derivative. So what is beta 1 hat? Beta 1 hat is the effect of effect of the change in x1 on change in y hat when x2 is 0. And x2 is 0 means what? The person is a female. So beta 1 hat measures the effect of education on wages for females. Now, what is the other possibility for x2? If x2 is 1, if x2 is 1, then the effect of education on wages is beta 1 hat plus beta 3 hat. So what is the effect of education on wages for females? It is beta 1 hat. What is the effect of education on wages for males? It is beta 1 hat plus beta 3 hat. So what is beta 3 hat measuring? Beta 3 hat is measuring the difference in the effect of education on wages for male versus female. That means if beta 3 hat is non-zero, is non-zero, then we will say that the effect of education on wages is different for males and females. However, if beta 3 hat is 0, then you will simply say that, okay, there is no difference in the effect of education on wages for males and that is, males and females do not have a different slope as far as the effect of education on wages is concerned. That doesn't mean that education does not affect wages, okay? Education affects wages, but it's just that it doesn't affect differently for males and females. Are you understanding this?
Yes, sir.
Okay. So that is when you will include the interaction term. And interaction terms are many times interesting because interaction terms is what makes it okay. I want to find something that has different effect based on the context. It changes the relationship between two variables. Okay. Is this clear? So, for example, there was there is a Nobel laureate, Oliver Hart. So Oliver Hart has done some very interesting work using math and economics. He was a mathematical modeler. So the one of the questions that he asked was, how do you manage prisons? In US, prisons are managed. Some prisons are managed by the government. Some prisons are managed by private companies. I mean, companies can bid and they can maintain the prisons. So now the question is, how do you know when should you actually give this task? When should government manage the prison versus when should private companies manage the prison? And most of the times the interesting answer is it depends. And then you come up with conditions. Depends on what. So he wrote a paper wherein the conditions on which it depends was something like this. Let's say you have a very crowded prison. Okay, you have a extremely crowded prison. Prison is overpopulated, so to say. When the prison is crowded, you don't want to give it to private body. You want the government to manage the prison. The reason for that is government will not think about cutting the costs, and cutting the costs in a crowded prison would be dangerous. So you don't want to cut costs there. On the other hand, if the prison is meagerly populated, that is, it's undercrowded, then that's when you would want to give it to the private companies, because they can cut the cost. That's not a problem, and they will come up with innovative ways to reduce the cost. So you want to create that incentive, or you want to allow the private companies to experiment and come up with ideas to reduce the cost, because the government doesn't have any incentive to reduce the cost, because they don't have the same pressures as a private company has in terms of reducing the cost. I mean, when I say private companies, I mean the non-government entities. uh, I don't mean the private and public companies in the way they are differentiated. What I mean is non-government entities, because the non-government entities managers are answerable to the shareholders. I mean, technically, the politicians are also answerable to the public, but public doesn't have the same kind of power to um, make the politicians accountable. So they don't have the same level of incentives as companies have to reduce the cost. So those are many times an interesting questions to investigate. That okay, I find the result is true in one situation, but the result changes in another situation. It flips, and those are the kind of things where you will say that okay, this is an interesting area, or the interesting question that I want to um, solve. So like that, lot of times you want to investigate whether the slope is different based on the values of other variables. Okay, is this clear?
So in the present example, wouldn't I mean the present population can change over time, but the ownership of a prison cannot, right? So for example, if a prison goes from underpopulated to overpopulated, what do? I mean, you keep it with the non-governmental
That's
entity, or
so you start changing the strategy of how to manage it. Like how I mentioned about Amazon. Amazon has changed its strategy in the last 10 years. Now it has its own vehicles to deliver the packages. It has its own aeroplanes to deliver the packages. The reason why it does that is it wants to reduce the time required to deliver, and it doesn't want to rely on other entities to do the same task, because when you rely on other entities, the quality may take a backseat, right? you
Um,
co- you you may not have the same control over the quality as you will have when you are doing it on your own. Now when that is the case, and why do you want to do that? Why that quality becomes extremely important? Because you are heavily reliant on the prime services that you offer, so you get revenue. So services, people will only continue with the services if they find value in those services. So same is the case with prison. When the prison is overcrowded, quality becomes an issue, and quality and cost are generally trade-offs. So if you want to improve quality, you will have to compromise on the cost. When you focus on cost, you will have to compromise on quality. So when quality becomes important, that is when prisons are heavily populated. You don't give it to the private companies. You keep it in person. Same is the case with schooling, right? People who do homeschooling, what is their biggest concern? The biggest concern is that the quality is not that great. So I'm not going to outsource education anymore. I'm not going to allow others to tell me what is the right thing to do in terms of education. I'm going to take the task in my own hands. And what is the main concern? The main concern is that the quality is low. But why do we all accept going to schools? Because we also know that it's extremely costly to educate a child at home. So you don't want to bear that high cost, so you do a cost benefit analysis, and then and somehow settle to a mid route, saying that okay. And why schools are able to reduce the cost? Because they get benefits of large scale, because you can teach multiple kids at the same time. Whereas when you are doing homeschooling, you are focusing only on, so you don't have the scale. You're basically manufacturing fewer products, so you can't get the cost benefit when you are doing. So it's the same idea when you do homeschooling. I think it's much easier to think about why to do homeschooling and when to do homeschooling if you start thinking about it as a problem of outsourcing versus insourcing, that is outsourcing versus uh, manufacturing something on your own. When do you outsource? I mean, when quality is not a big issue, you can monitor the quality and you want to reduce the cost. When do you keep it in house? When quality cannot be monitored, or you feel that the quality is a big issue, you want to maintain the quality, and you can bear the high cost, you accept the high cost that comes with that. So it, I mean, it becomes a very simple problem to think about when you start thinking from this angle about what should I do. Okay, is that clear?
Yes.
Okay. Now beta 1 hat is interesting only if x2 is 0, because if x2 is not 0, then beta 1 hat is not even, doesn't have any interpretation if x2 cannot be 0. And x2 is 0 is interesting when x2 is a binary variable, because if x2 is a continuous variable, so let's say x2 is age. If x2 is age, then beta 1 hat is uninteresting. Beta 1 hat in itself doesn't have any meaning, because x2 is a non-zero variable. So beta 1 hat in itself doesn't have any meaning. Okay. So if beta 3 hat is greater than 0, then we say that the effect of x1 increases with the value of x2. Okay. So if x2 goes up, then the effect of x1 also is increasing. So this, this kind of interaction you can do for testing whether something is a substitute or a complement. What do we mean by substitute or complement? Complement means if you increase one variable, the effect of the other variable will also be positive. Whereas if they are substitutes, when you increase one variable, the effect of other variable will reduce. Right?
So when you
can
interact
think
two
of
variables, one of them must necessarily be a binary,
no, not necessary. They can be continuous.
but then one
There
of
is
the coefficients will lose their meaning.
yeah. So what you can do is maybe you can demean the variables before you interact them. Because when you demean it, then you can substitute x2 as x2 bar, and your beta 1 hat will interpret that as the effect of x1 on y hat holding x2 equal to the mean value. So basically you have to find out what are the interesting values of x2. So demeaning is just because x2 is equal, substituting x2 is equal to mean is interesting. You can also substitute x2 minus 10. You can subtract 10 to artificially bring some of the values to 0. Does that make sense, Ashwat?
Yeah, it does. For example, if it is age, maybe I just do x2 minus 27 to look at the effect on people about 27.
Yeah, exactly.
All right.
So you can basically you can substitute different values of x2 and compute what is the effect of x1 on y hat. The demeaning is just for to help people just look at beta 1 hat and interpret that beta 1 hat. Because then you don't have to keep explaining, see, the effect is beta 1 hat plus beta 3 hat times x2, and I substituted different values of x2 and here are the results. You can just tell people what is x1 and they would get some intuitive sense of how the scaling up and down is going to take place from there.
The AP is average partial effect, right?
Yes, average partial effect. Yes. Average partial effect is you take this partial effect. Why it is called partial effect? Because you found out the partial derivative.
And then you
And
take
you
an average of all the variables,
all the observations, So for the first observation, I will go and change the value of x1 and take the original value of x1 and compute the compute the y hat, holding all other variables same. I will do that for the second observation as well. I will do that for third observation as well, and so on and so forth. And then finally, I will compute what I actually get as average partial effect. Okay. And what is interesting with, in the courses that Wooldridge will do, he will actually calculate, he will show the calculations by hand. I mean, when I say by hand, of course, in Stata, I mean, yesterday what we did was we computed things by hand. When I say by hand, it's in Stata, but you actually see the computations. You actually see that these formulas that we have discussed, we are using that to see how, we are verifying it in that context. So you would actually calculate the average partial effect and then use the command in the software and show that, okay, both of them are same. So you have some idea that what is happening behind the scenes, because many times what happens is you don't know what is happening behind the scenes, and when you don't know what is happening behind the scenes, you sometimes do not have the same confidence in explaining to people exactly how these things work. And also, what is happening behind the scenes is extremely helpful when you are actually doing this analysis, because when you don't know what is happening, then you can do some garbage in, garbage out. If you put garbage in these softwares, what you will get is just garbage. I mean, it will have no meaning at all. Then you will be making the claims such as, why can't you argue that X and U are uncorrelated? In my data, I find that X and U hat are uncorrelated, and therefore I'm going to conclude that X and U are uncorrelated. But those two are two different things altogether. When you say X and U hat are uncorrelated, it's an algebraic property. There is nothing to even argue over there. That is obvious, or we know that is true. X is uncorrelated with U is what we is what we are all looking for. I mean, that's where there will be disagreements, because people may not believe that in the population actually that is what happens. Okay. So if beta 3 hat is greater than 0, the effect of x1 increases with the value of x2. So what is the average partial effect? So the average partial effect is beta 1 hat plus beta 3 hat times x2 bar. How that has become x2 bar? Because you are adding up all the cases and dividing it by n. So you're taking the average. So basically you don't even have to do all these computations. You just take the average of x2 and plug it in this case. That will be same as going through each and every observation and finding out y hat for the given values of x2, and then you change the value of x1 holding x2 fixed. So you will get another value for y hat. So you will have y1 hat when you keep the x1 at the same value as you have observed. Then you change the value of x1 to some other value, and then you again compute y1 hat. Like that, you will do it for every observation, and then you will average it, and that's the take the difference and then take the average. That be the average partial effect. But you can do a shortcut. You can average x2 and then find the partial effect. Okay. Instead of this, you can center the variables before the interaction. And I'm not going to do the math. And the claim is that gamma hat is actually equal to beta 3 hat, but gamma 1 hat directly gives you the average partial effect. Gamma 1 hat directly gives you the average partial effect. And gamma 2
makes
hat
sense too. I mean, it should give you the average partial effect because you are centering it.
Yes, that's the whole objective of centering the variable. Many times what happens is, the PhD students, a lot of times, we discuss a lot among ourselves, and a lot of times they come with this troubleshooting. They say that, oh God, when I interact the x1 with x2, my x1 variable earlier, I got the results, the effect was significant. When they say effect was significant, means their p value, you remember the table where it had the p value was quite low. But when they interacted, the p value was pretty high. That means it was not low anymore. So the first question I will ask is, did you center the variable? And most often they will say no, and then I will say, yeah, that's not surprising that don't get significance with x1. Go back, because why do you not get significance with x1 anymore is that your derivative is this, which is this, and x2 is equal to 0 is not an interesting case at all. You don't have an x2 is equal to 0 possibility in your sample. So that's why you're not getting good results. You have to substitute different values of x2 to even interpret that beta 1 hat. But if you center it, then your beta 1 hat automatically gets an interpretable, it automatically gets interpretability. And then you'll see that, the results are similar to when you had not interacted x1 with x2. So centering is always a good idea. It is always a good idea to center the variables before you interact.
Centering is xi minus x bar.
Yes. Basically, you take the mean and you reduce it. That's what that's what the centering means, or demeaning. What we called as demeaning. So the net financial wealth data set. So E401k is whether or not you participate in saving scheme, like whether or not you participate in the pension funds, age, income, and then 401k is interacted with the age. So you may anticipate that depending on your age, your participation varies. And then 401k is also interacted with the income. That is, with income, with higher income, you are more likely to participate. Higher income, you are more likely to participate. As you get older, maybe you invest, you participate in the 401k. Initially, you think that, okay, I don't need to save money, so I don't even invest in wealth. But as you grow old, maybe you realize that you want to invest in 401k. Okay. Okay. Can somebody calculate this? This divided by this number divided by this number. $591,446.212.
0.1295.
That is your R squared, right? Because what is this? This is SST. What is this? This is your sum of the squared explained by the model. This is your SSR, sum of the squared residuals.
I shouldn't have brought out my calculator for that.
Sorry?
I shouldn't have brought out my calculator for that. Should have just seen it right there on the screen.
No. The idea was that, to verify that actually it gives you the R squared. And these are your degrees of freedom. So how many observations are there? 2017 observations. So the total degrees of freedom is only 2016. That means if I give you 10 values, or if I tell you that the sum of 10 numbers is X, how many values can you take without any restriction, or how many values can you take with freedom? You can only take 9 values with freedom, because the 10th value has to be adjusted in such a way that it gives you the sum. So similarly, when you have 2017 observations, you can only take 2016 observations with freedom. The 2017th observation has to match with whatever condition that I have asked or given to you. What is this 6? 6 is telling you how many regressors do you have, how many regressors that you have included, like 1, 2, 3, 4, 5, and 6. So the higher the variables you include, that degrees of freedom will go up. And then you have the residual, which is the remaining degrees of freedom. So cons is just a constant. So this is your beta naught hat. Or in Wooldridge's notation, it is beta 1 hat, because you remember the variables start with x2 anyways. So that's your constant. And if you see, the p is what is telling you whether the results, do you have the results or you don't have the results. Okay, just the number is, just the coefficient is not important. You want the p value to be smaller than 0.05. You want to expect the result to hold true in at least 95 of the samples out of 100. You want the result to hold true in 95 of the 100, 95 samples out of the 100 possible samples. That means you are still going to have some error in your estimation. Okay, like if you go for a COVID test, you may be tested positive, but there is no 100% guarantee that you actually have COVID. Similarly, you may be tested negative, but that is not necessarily mean that you do not have COVID. And in that case, actually, it may be better to, come up with false positives than coming up with false negatives. Why do I say that? Is that false negatives are dangerous because of the network effect. So if you have a negative report, but if it is false, then you may not quarantine because you are not negative, you are not positive, but then spread. If you are false positive, yes, it is extremely costly because you have to quarantine yourself, but it is less costly for the society as a whole. So it's costly for individual, but it's less costly for the society. False negatives are extremely costly for the society. It may not be that costly for you as an individual. Maybe it's still costly because, but that would have been the case even if for you, it's actually less costly. I mean, it depends upon the intensity, right? Probably false negatives have low intensity of that. So you will have to determine how much accuracy you want, whether you want the results to be, whether you want the results to be expected in 95 samples out of 100, or you are going to say, no, I 95 samples out of 100 is not good enough. I want the results to be true in 99 out of 100 samples. Then you will say that I want the p value to be smaller than 0.01. Sorry. Then I will say that 0.01. The possibility. So what is this? What is this number saying? The number is saying, suppose the mean of the distribution is 0, then how likely are you to have the coefficient greater than 0? So your coefficient is something like this, 0.7, and there is only 0.000 probability that this is actually equal to 0. Note that when I use the word it is equal to 0, I am not using equal to 0 in a mathematical sense. Obviously 0.70 is not equal to 0. The question is whether 0.70 is enough to conclude that it is that the beta coefficient is actually not 0. So it's like tossing a coin, and let's say you toss the coin 100 times, and you expect the number of times the heads to arrive is 50, at what point of time will you say that the coin is biased? If you get 55 heads, can you say that the coin is biased? If you get 60 heads, can you say that the coin is biased? That's when we say that, oh, 60 is not different from 50 in a statistical sense. Of course, 60 is different than 50. What do you mean by 60 is not different than 50? 60 is different than 50. But it depends upon the distribution, how wide the distribution is. Sometimes even numbers like 0.5 may be significantly different from 0. And sometimes 60 may not be significantly different from 50. Are you getting what I'm saying? So you have to be very careful because how do you calculate your t statistic? Your t statistic is calculated as the coefficient divided by standard error. If you divide the coefficient by the standard error, you will get the t statistic. And t statistic, anything greater than 2 is a good news. I mean, greater than 2 meaning the absolute value of t. Because when t is equal to 2, that's when your p will be 0.05. So the moment you see the t values are greater than 2, you will see that the p value will be smaller than 0.05. So look at this one. This is bad news. I mean, bad news in the sense that there is no effect of gender on net financial wealth. What do I mean by bad news is that you don't get a significant result. That means I cannot say that the gender has any effect on your net financial wealth. Males and females are equally likely to have or males and females do not have different levels of financial wealth. That's what this data set is saying. Okay, so what is this interaction term telling you? This interaction term is telling you that we know that people who participate in the investment or who participate in the pension program, their net financial wealth is smaller. But for people who have a higher wage and they participate, it has a positive effect on the net financial wealth. So note that this is an uninteresting value now. Why it is an uninteresting value? Because that will be the effect. Minus 23 will be the effect on net financial wealth when the age of the person is 0. Are you understanding? Minus 23 is the effect of E401k on net financial asset and financial wealth when the age is 0. And age is 0 is uninteresting. That's why this number minus 23 doesn't make any sense. So it is not surprising that you have got something that doesn't make sense, because you would expect that people who save money should have more net financial wealth. Same is the case here, right? You're assuming that the age is 0 and income is 0, because what is the partial derivative of E401k on net financial asset? It is this plus 0.480919 times age plus 0.34065556 times income. Is this clear to everyone? Is it clear to everyone? Okay. So
Yes, sir.
last point I will make. I think it's, what is the time right now?
Sir, it's 10:05 a.m.
Okay. So 10:15 is a SARP session, right?
I think it's 10:30.
It's 10:30, is it? 10:30 to 11:15. So I will quickly finish this point. Now what you are doing is you have demeaned the age and you have demeaned the income. Now if you see this number makes sense. This number is sensible. You can see that R squared has not changed. Nothing changes. See, R squared has not changed. R squared has not changed. Age variable has not changed. Only the E401k has changed. Age has not changed. Income has not changed. See, age and income, they are exactly the same. What changes is this changes. This changes. Male is also not changed. It is also same. And now this makes sense. Now what you are saying is for holding the age and income at the mean values, people who participate in the 401k or they participate in the investment program or they save money, their net financial wealth will increase. And you can see that it goes on increasing. So the effect is not constant. So the effect is not linear. The effect is non-linear. That is, not everyone will have the effect of increase in net financial wealth as 5.0601756. In fact, it will go on increasing. It is 5.601756 plus 0.48099193 times age over and above the mean age. So as you increase the age above the mean, your effect goes on increasing. And anything below the mean, actually the effect is smaller than 5.601756. The effect is smaller than that number. Okay. So there is this figure, right? Adjusted R squared. Actually, adjusted R squared is what is important, not the R squared. You remember we said that R squared can be increased by just adding more variables. We had discussed this point that we can increase the R squared by just adding more and more variables. Right? We had discussed that point as a constrained optimization problem. You adding more variable just reduces the U hat and there. So adjusted R squared will penalize you for adding nonsensical explanatory variables. So that's why you want to focus on the adjusted R squared. It is actually charging you a penalty for including too many regressors when you don't need to include that. How does it do that? We will not discuss that because that will need more math and I don't want to go there right now. Okay. Similarly, when you use logarithm, then you can find out the change in log of a variable as change in the variable divided by the starting value. So change in log z is measuring a percentage change in z, because change in log z gives you the relative change in z. So how do you calculate the change in log z? Change in log z is log z1 minus log z0, right? You take some value of z and you subtract the original value. And note that log z1 minus log z0 is approximately equal to z1 minus z0 divided by z0, which is change in z divided by z0. Can somebody tell me from how do you go from here to here? How do you go from the approximate change is actually z1 minus z0? How is the change in log approximately equal to the percentage change?
Because the derivative is 1 by x.
Okay, so
let me phrase this properly. So we can simply estimate dy by dx is delta y by delta x, right? So
yes,
delta will be approximately delta x into derivative
so
of log z.
let's say y is equal to log x. Okay, y is equal to beta times log x. Okay, so what you are saying is dy by dx is equal to beta by x, correct?
Right. And we can approximate this as delta y by delta x. So delta y is approximately delta x by x into beta.
Beta times delta x by x. So delta x by x is nothing but your relative change. So when you multiply both sides by 100, you will get, when you multiply both sides by 100, so you get 100 times the change in y is beta times the percentage change in x. Percentage change in x. Right? And what is delta y? Delta y is nothing but your beta times delta log x. Beta times delta log x. So I can write it as 100 times beta times delta log x, because delta y is same as your delta log x. How? Because you can see that delta y is actually beta times delta log x is equal to beta times percentage change in x. So beta will cancel out and you will get 100 times the delta log x is equal to percentage change in x. Okay. So note that this will only work when the delta z is actually very close to 0, because for derivatives you want the change in x to be very small. So the change in x has to be very small. Change in this case, because the variable used is z, the change in z should be very small. Okay. So this is exactly what we discussed just now, that how do you interpret the beta 1 coefficient. So 100 times the beta 1 coefficient will give you percentage change in y hat. So what you will do is you take beta 1 hat, you multiply it with 100, and you will say that that's the percentage change in y. That is the percentage change in y when x1 changes by 1 unit. X1 changes by 1 unit, or the change in x1 is when other variables held fixed. Okay. So the log can be interpreted as a percentage change. So if you have log on both sides, it becomes an elasticity measure. If you have log on both sides, then you're measuring the percentage change in y because of 1% change in x. Because of 1% change in x. Okay. And I will stop here. Okay. Yeah, this is what I just mentioned. It gives you the percentage change in y hat due to 1% change in this thing. Okay. So we will stop here and we will meet again at 11:30. So you have start session from 10:30 to 11:15, I guess. And then we will reassemble for 11:30 to 12:30. Then you will have lunch break till, I don't know, 2:30 possibly. And then 2:30 to 4, Adityan will take the session. I think that's it. Then I think maybe Muralidharan sir has a combined session in your batch. So the same meeting ID for our session at 11:30. Okay. See
Okay,
you
so
all
can
soon.
we quickly
Sorry?
take